In this video, I will explain how to solve a free fall problem in physics that involves dropping an object. So let's jump right into an example. This says a ball is dropped from the top of a building that is 380 meters high. We want to know how long does it take for the ball to hit the ground, and we want to know what is the velocity of the ball just before hitting the ground. So let's go ahead and just sketch a quick picture of what we have here. We have some building that's 380 meters tall. Let's say there's some person at the top. They're dropping this ball straight to the ground. And we want to know how long does it take for the ball to hit the ground. So when we're doing a free fall problem like this, one really important thing that we need to know is what is the acceleration of gravity? So when this ball is dropped, what is the acceleration? Well, the acceleration, we can say A, that's going to be equal to negative 9.8 meters per second squared. This is the acceleration of gravity, so you have to know this value. Now, when we're solving this problem, the acceleration is going to be constant all the way down. So we're going to be able to use the kinematic equations in the field of physics, and these are equations that you can use to solve problems when you have constant acceleration. So to decide which of these equations we should use, let's write down what variables are we given. So we'll say we know the acceleration A. We also know the initial velocity of this ball. So initially this ball just has a velocity of 0. So VI, initial velocity, it's just going to be 0. It's at rest before it's dropped. Now, we're also given the displacement of this object. So the displacement of an object, let's write that right here, displacement, that's equal to the final position of the object minus the initial position. So in this case, we're saying the ground is the final position, which is 0 meters tall. And the initial position all the way up here, this is 380 meters. So our displacement is going to be 0, the final position, minus the initial position of 380, which is just negative 380. So we're also given the displacement. Now, what do we want to find? We want to find the time, which we'll write t. So these are the variables we're given and the one we want to find. So let's look at our kinematic equations over here and say which ones involve these 4 variables right here. So if we look through our kinematic equations over here, we can see that equation 1, 3, and 4 all involve the final velocity, v sub f, which we are not given. So we can't use any of those equations, so we'll have to use equation number 2 to solve for the time. So let's go ahead and write that out. We have the displacement, which we said was negative 380, is equal to, we have the initial velocity times the time. So again, the initial velocity of this ball is 0. So we have 0 times t, which we don't know t, plus 1/2 times we have acceleration, which we said is negative 9.8. And then that's multiplied by t squared. So we're trying to solve for t. So let's simplify a little. We get negative 380 is equal to, this is 0, 1/2 times negative 9.8, that's negative 4.9. Then we have t squared. To solve for t, we'll divide both sides by negative 4.9. These negative 4.9s will cancel out. On this left-hand side, we have a value of 77.55102. And on the right-hand side, we have t squared. So to solve for t, we're just going to take the square root of each side. And the square root of 77.55102, that turns out to be, let's write it right here, t is equal to plus or minus 8.81. And our units are seconds. Now, when we're talking about time can't be negative, so we're not going to use the negative version. So our final answer is going to be 8.81 seconds. That's how long it will take for the ball to hit the ground. So let's go ahead and write that right here. Okay, now we want to solve the second question here. What's the velocity of the ball just before hitting the ground? So I'm going to clear a little bit of space right here. Okay, so what is the velocity? So again, we're given these 3 variables, and now we also know the time. So let's say we're also given the time. And this time we want to find the final velocity. So the variable we want to find is v sub f, the final velocity. So if we look over here again at our kinematic equations, which one can we use to solve for final velocity? Well, it looks like we could use equation 1, 3, or 4. All of those involve the final velocity. But it looks like the first one is the easiest to use. So let's go ahead and use that first equation. So we have the final velocity, let's write that down, v sub f, is equal to the initial velocity. So the initial velocity of this ball is 0. And then we have plus the acceleration times time. So the acceleration is negative 9.8. And the time we just found was 8.81. So the final velocity is going to be Negative 9.8 times 8.81, that comes out to negative 86.34. And we're talking about velocity, so our units are meters per second. So that is the final velocity of the ball just before hitting the ground. And notice that it's negative, so the direction is negative. In other words, the height is getting lower and lower and lower until it hits the ground. That's why we have a negative velocity. So that is how you can solve a free fall problem that involves dropping an object.